Here we're asked to solve a radical equation. Let's begin by isolating this term that involves the square root. To do that, we'll add this term to both sides and also subtract 3 on both sides. Doing that, we'll be left with x minus 3 equals 3 times the square root of 3x plus 1. Now, once we get the term with the radical isolated, we then, in this case, square both sides. Now remember, squaring both sides introduces the possibility for extraneous solutions. So we better check our answer in the end. X minus 3 squared is x squared minus 6x plus 9. Squaring this term here involving the radical, 3 squared is 9 times 3x plus 1. At this point, we can see we're left with a quadratic. So let's get this in standard form equal to 0. Distributing the 9 here on the right side, we have 27x plus 9. And then subtracting 27x at the same time subtracting 9, we'll be left with x squared minus 33x equals 0. Now factoring this, we can see x is the GCF. Factoring out an x, we'll be left with x minus 33 equals 0. Now at this point, we set each factor equal to 0, so either x equals 0 or x minus 33 equals 0. And so our two possible solutions are 0 or 33. So let's check those. Substituting x equals 0 into the original equation, we have 0 minus 3 times 0 here would be 0, so 3 times the square root of 1. Does that equal 3? Well, here you can see negative 3 does not equal 3, right? So x equals 0 is an extraneous solution. We'll disregard that. Next, we'll check x equals 33. Into the original, we have 33 minus 3 times the square root. Substituting in 33, 3 times 33 is 99, plus 1 will leave us with the square root of 100. And we need to determine if that's going to be equal to 3. So in this case, we have 33 minus 3 times 10. And we can see here 33 minus 30 does equal 3. So x equals 33 is our only solution.